Hello, I am Ben Tennyson. We will learn about screen pixels. Do you believe these pixels in different shapes on the screen as you can look closer? Well, it's hard to see, but you can look through the microscope. These come in different shapes of pixels, from CRT monitors and televisions, LCD monitors and televisions, and other devices like laptops and smartphones. As we all know, it consists of RGB, that is red, green, and blue. When you invert it, this becomes CMYK, used for printing purposes. Now, can you note the possibility of RGB colors? If yes, have a look. Each color pixel ranges from 0 to 255, or in hexadecimal form, say, 0 to FF. Depending on the intensity of each color, this represents luminance from 0 to 100%. 0 refers to minimum, has no color, and maximum up to 100% consists of RGB. Next, the hue, making an angle from 0 to 360 degrees. We put red at 0 degrees. The rest of the two colors are green and blue. We have a total 3 colors. Green will now be marked at 120 degrees and blue at 240 degrees. If in case you see a new color, for example, suppose yellow has 100% red and 100% green. The average between 0 and 120 degrees is 60 degrees. If you see orange as well, we get 100% red and 50% green, that becomes 30 degrees. This forms like a rainbow in order, or you can see from the visible spectrum in units of terahertz and nanometers. Note the keyword trichromacy consisting of 3 colors. On combining them all, we get a white light. If you have inverted them, just as you have seen before, we get the hue opposite angle, like red transforms into cyan, shows its complementary color, with a difference of 180 degrees, or value of pi. If you invert it 50%, this will be one possible gray color, half RGB. And finally, saturation. Let us take a picture of me, as you can consider. The saturation is normal at the value 50%, between grayscale and high color. If the saturation is minimum, we will get the picture grayish in color. If the saturation is maximum, we get high saturated colors. This can be done in picture and video editing like Adobe Photoshop, Adobe Premiere Pro, Adobe After Effects, and others. We will now have many possible colors. First of all, take 8 primary colors: black, blue, cyan, green, magenta, red, white, and yellow. And then check out the possibilities, but without repeating any same color. If you make many more color possibilities, dividing into numerous values of intensities or hexadecimal, this will approach to color repetition as a formation of gradient. The equation we form 2 cubed plus 3 cubed minus 8 plus 4 cubed minus 8 plus 5 cubed minus 27 and so on. Representing them, up to 256 cubed, equals 16,777,216 possibilities so far. Now, one thing about pixel is aliasing and anti-aliasing. Aliasing refers to each of a set of signal frequencies which, when sampled at a given uniform rate, would give the same set of sampled values, and thus might be incorrectly substituted for one another when reconstructing the original signal. The line appears to be quite jaggery. For example, old Windows version running on old computers in 1980s or 90s, also old arcade video games like Space Invaders. On the other hand, anti-aliasing is a technique used in digital imaging to reduce the visual defects that occur when high-resolution images are presented in a lower resolution. For example, high-quality games, high-quality pictures and movies and much more. That's it for this topic. Like, comment, and subscribe.